Hello ladies and gentlemen, this is Dean from Multiply, and today I want to impart some of my knowledge onto you. Linear algebra here is one of the, if not the hardest course I've ever taken in school, and I want to make some videos to clear up some of the challenges I've had and to teach newcomers a little so that they can get an introduction to linear algebra from a student's perspective. Now when I say that linear algebra is hard, I don't mean that the math is difficult. In fact, it's usually quite easy, and generally you won't expect calculators to be allowed in linear algebra exams because it's all mental math that you can do in your head, mostly, at least in the earlier levels. However, the concepts are challenging and the methods to solve problems might be a little hard to remember, so I can bring up shortcuts and tips as they become apparent. Just for perspective, the average on my linear algebra 1 midterm was 40%, and hopefully nobody comes out of this with that type of mark. That being said, why don't we talk about why linear algebra is important? Suppose you wanted to find the intersection of the lines that I have here, y equals 9 minus 3x and y equals 5x minus 1. Well, let's pull up a graph here and see what it says. This is just a graphing calculator, and this says that it is at 1.25 and 5.25. Well, that's great. What if we wanted to look at 2x minus 8y is equal to 7 and 4x minus 9y is equal to 12? Right away, you can see that the solution here isn't going to be quite so simple because the coefficients on the y variables are going to be denominators if you move everything so that it's in terms of y instead of this linear form here. The calculator here tells us that the coefficient or the coordinates of the intersection are a bit more messy. They're not nice round fractions. 3.18 and negative 0.08 are to 2 decimal places, which even at this point is fairly simple. But let's look at how you would solve this algebraically. So, if you've taken high school maths, you probably should have seen this. They're already in linear form, which is nice. And so what you want to do is you line them up, as I've done here, and you go ahead and add a subtraction sign and a little coefficient there. So that way you have your 4's line up and they'll cancel like that. And you just subtract through, so 9 minus negative 16 is 25. 12 minus 14 is negative 2, and so you get 25y is equal to negative 2. Divide 25 on both sides, and you find that y, that's not there yet, y is equal to negative 2 over 25, which I don't have written down here, but it's pretty easy to see if you remember anything out of algebra. Now choose one of these original lines, and let's just do this the top one here, because that way the negatives will cancel. And there you get 2x minus 8 times negative 2 25ths is equal to 7. You can also just express that by multiplying the 8 in and get 2x plus 16 25ths is equal to 7. 7 times 25 is 175, so 2x is equal to 175 minus 16 over 25, because that's how subtracting fractions works. Divide the 2 out. Oh, also, 175 minus 16 is 159, which you should be able to do in your head if you're taking linear algebra or interested in it. Divide the 2's and you get x is equal to 159 over 50. Well, let's look at the calculator. Negative 2 over 25, which is what we said for y, is negative 0.08, which is what we have. And 159 over 50 is 3.18, which is that. So it works. But what if you had some more variables like z, a, b? What if you had more equations? Pretty quickly, system of equations, which is what these are called, can become pretty complicated. And their solutions can be pretty weird too, at least if you're expecting a simple point on a graph. And in the next video, we'll look at what we can do to make that a little easier. So I'll see you then.